Welcome to the Inorganic Chemistry series. This video focuses on reactions and pH. At the end of this lecture, students should be able to understand the basic chemical reaction components, demonstrate knowledge of acid-base chemistry, and identify types of solutions at varying pH. A chemical reaction occurs when one or more substances is changed into other substances. Reactions typically occur in a liquid, and most often that liquid is water. However, there are reactions that occur between chemicals or elements in a dry environment. Reactions are written as a sentence, with the reactants on the left side and the products on the right side. The direction of the arrow indicates which way the reaction can occur. The reaction always moves from reactants to products. However, in some reactions, the products can now become reactants as well. And then the original reactants now become the products. Sometimes reactions proceed forward, and then the reactants are no longer used or needed, and the products become new reactants for another chemical reaction. So there was an intermediate compound formed. These reactions that go forward and then backward are known as reversible reactions. The goal of any reaction is to reach equilibrium, or a state of balance. In the case of non-reversible reactions, they just want to reach completion. Often reactions use a source of energy to speed up the reaction, and these sources of energy are enzymes, and they're known as catalysts. Solutions are simply reactions in a liquid media that form a mixture. In order for solutions to form, we must have the liquid or solvent, and the item being dissolved or solute. In aqueous solutions, the liquid or solvent is water. Water is known as the universal solvent, as it can dissolve more solutes than any other liquid material. When solutions form between ions or molecules with polar covalent bonds, solvents are hydrophilic or water-loving, and they readily dissolve in water. Other reactions occur outside of water, or in water, but the solutes do not dissolve because they're hydrophobic or water-hating, water-fearing. Other end is hydrophilic. These are called amphipathic molecules. There are various types of mixtures that form. A homogeneous mixture occurs when a solute dissolved completely in the solvent. In homogeneous mixtures, you cannot see the solute particles in solution. A visual image is when you add drops of food coloring to water. The solution mixes completely and you cannot see the individual units of food coloring once the molecules are distributed in the solution. When salt is a solute added to water, the solvent, the resulting solution is homogeneous. Another form of a homogeneous mixture is a colloid. Colloids are mixtures with particles that do not fully dissolve, yet are small enough that they do not settle out to the bottom of the mixture. These are things like milk or gelatin. You might need a microscope to see the components of milk, but they're distributed evenly throughout the solution. By contrast, heterogeneous mixtures are such that you can easily see the solute particles in solution. When you go to the beach, the sand and the ocean combine, forming a mixture. But as the water calms, the sand settles to the bottom. This heterogeneous solution is known as a suspension. Chocolate milk, orange juice, they are both suspensions. When left alone, the solute, the chocolate, will settle out to the bottom. Or with orange juice, the solute, or the pulp, will settle out to the bottom of the solution. When we look at water, the polarity allows the solvent to ionize. When water ionizes, it forms hydrogen cations and hydroxide anions. Acids are solutions that release their hydrogen cation in solution. Strong acids release more hydrogen cations than weak acids. Conversely, bases can release a hydroxide ion or accept a hydrogen. They readily bind to the hydrogen cation in solution. Acids increase the amount of hydrogen ions in solution, where bases decrease the amount of hydrogen ions in solution. Acidic items taste sour, like a soda or batteries or lemon juice, vinegar. And basic or alkaline items have a bitter taste, and they're slippery, like soaps or cleaning cleansers or baking soda. Acids and bases are measured by the pH scale, which uses the amount of hydrogen atoms in the solution to determine the pH. The scale runs from 1 to 14. Neutral solutions have a pH of 7. Solutions that are acidic are lower than 7, while solutions that are basic are greater than 7. The pH of a solution affects the function and the shape of the molecules in a reaction, as well as the reaction rate. pH alters the ability of molecules to bond and changes the ability for ions or molecules to readily dissolve in water. Buffers are solvents that help solutions to maintain a constant pH. In life, organisms usually tolerate a very limited range of pH change. Buffers help to keep the environment tolerable. The acid-base buffer system shifts reactants and products to remove or release hydrogen ions to minimize a change in pH. These reactions readily convert between intermediate forms and proceed forward or reverse based on the needs of the reaction pH. After this lecture, students should understand atoms, molecules, compounds, and elements. We should be able to identify or differentiate between types of mixtures. We should be able to describe how the pH scale and buffers work. And we should be able to identify the parts of chemical reactions and parts of solutions.